Way back when I was 6 years old, reading comic books, and I loved comic books. In the centerfold of a Superman comic book was a description, not a comic, but text, of how to build something called a crystal radio. And what fascinated me was that you could build it out of parts you could find in your house or on the street at no cost. I mean, I needed an empty toilet paper roll, some wire, my father's old razor blade, a pencil lead. That was pretty much free. I needed an earphone, which I stole from the candy store's telephone booth. And I needed something called a variable capacitor. I had no idea what that was, but I knew I could buy it down on Canal Street. So my mother took me down on the subway. I walked to the first electronics shop, banged my fist on the table and said, "I need a variable capacitor." And the guy said, "What size?" And it blew my cover. So I explained what I wanted it for. He says, "I know just what you need." So he sold us for a few pennies this variable capacitor. I brought it home, wired it up, and I heard music coming out of the earphone. No battery, no power, basically free. Now this was clearly magic. I decided I better figure out how this works. And that's what launched me on this career, if you will, of engineering. And I'm still trying to figure out how it works. Went to graduate school at MIT, and there I started working for the legendary Claude Shannon, the man who invented and created information theory. Brilliant guy, and he was then and still is my role model. And I noticed that all my classmates were doing their PhD research on the area that he had created, information theory. And in my mind, this was a very crowded area. Shannon had done most of the easy, good work, solid work. What was left was hard and probably inconsequential, so I imagined. But I was surrounded by computers, both at MIT and at MIT Lincoln Laboratory, where I spent my summers working. And I said, one day these computers are going to have to talk to each other. And there was no adequate way by which they could do so. So this really challenged me. This is a good problem. It'll probably be important. There's a lot of low-hanging fruit. Let's go for it. So I started working in the area, which eventually became the internet. And what I did for my dissertation was to basically create the mathematical theory of data networks, suggested and introduced the idea of taking messages and breaking them up into fixed-length blocks. We now call those things packets, and developed the underlying technology of packet switching, which now drives the internet backbone. So September 2nd, 1969, the first packet switch, we now call those things routers, arrived in my laboratory at UCLA. It was based on a design that we had specified the manufacturer create. It arrived there on the Labor Day weekend. On the Tuesday following the Labor Day, we hooked that switch up to our host computer at UCLA. The host computer was basically a time-shared computer serving the computer science department at UCLA. So we had a switch and we had a computer. It wasn't going anywhere, but I like to say that that's the day that the infant internet took its first breath of life. This switch, which was part of the internet, looked out into the world, was born, and saw a computer. A month later, the second node received their switch up at Stanford Research Institute, otherwise known as SRI, 400 miles to the north of UCLA. They're up in the Bay Area. We put a high-speed line between our switch and their switch. They connected their computer. We had our computer. And what we wanted to do was now talk from our computer through this very small two-node network to their computer. This was October 29th, 1969. So what was the message we wanted to send? All we want to do is log in from our computer to their computer. Now to log in, you have to type LOG, and that remote machine is smart enough to know what you're trying to do. It types the IN for you. Ready to go? Charlie Klein, my programmer, and myself, Bill Duval up at the other end, and we had a telephone connection so we could communicate and make sure we watched what happened. So we typed the L and we say, "You get the L?" He says, "Got the L." Tap the O, you get the O, got the O. Tap the G, you got the G, crash. the SRI computer crashed. So the first message ever on the internet was lo, as in lo and behold. We couldn't have anticipated a shorter, more prophetic, more succinct message than lo. 2 months before the September date, on July 3rd of 1969, a press release was put out of UCLA. And in there I'm quoted in writing, I've got a copy of the press release, where I do articulate the vision I had. And basically what I said was that the internet would be always available, always on, everywhere, that anybody with any device could get on at any time, and it would be invisible, just like electricity is invisible. What I did not anticipate was that my 99-year-old mother would be on the internet, and she wasn't until she passed away 2 years ago. I didn't see the social side. Our vision then was computers talking to each other and people talking to computers, but not people to people. And of course, that's what's driving the internet these days. The communities that form, the Facebooks, all the social networking, all the email is about people communicating with each other. Miss that side of it.